Hello class, this is Mr. Kusaj. Welcome to the notes for lesson 6.3, solving linear systems. So what we want to do is, as you can see, if you look ahead here at the example, we want to solve a system, and there's two ways we can use this using matrices. One way is if we use the inverse matrix. Okay, so you have a matrix times the variable equals another matrix. Then what we're saying is the variable is equal to the inverse of the original matrix, right? The inverse of the original matrix times B, the given matrix. Okay, it doesn't make sense right away, but when we use it, you'll see what we're talking about. Just keep in mind that you will need to know how to find the inverse of a matrix. Okay? So here's an example. Here's my system of equations. I can change that. I can change that to this. Right? So this left side becomes 2, -3, -3, 5. The variables are x, y, and they're equal to -1, 3, right? So we didn't do it this way before. So this is another way of doing it, but this time we're going to use the inverse. So if we consider this to be the A matrix and this the B matrix, what we're saying is then the variable is equal to the inverse of this times this. Right? So we know how to get the inverse, and we know how to do times. We know how to do multiplication with matrices. So first, we need to find the inverse of this. Really quickly, off to the side, let's find the inverse of our matrix A. So, if you recall, the way to get the inverse is 1 over the determinant of A, right? Remember, cross multiply, subtract. Okay, I know I'm going through this quickly, but we already did inverse of a matrix. So all I'm doing is finding the inverse of a matrix times the swapping of the numbers. Remember that? You switch the numbers and then you change the signs. There it is. So what that gives me is, if you go through it, here is the inverse. This is the inverse of A, right? This is the inverse of A. So now what I'm going to do is get rid of this and multiply this by the inverse we just found. Here it is. Right? Isn't that what the rule up above told us? So xy, our variable matrix, is equal to the inverse times the B matrix. Right? So now all I have to do is multiply these two, and I'm done. So how do you multiply? You remember, going across, going down, boom, 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 and your answers, and you're done. So that comes out to -5 plus 9. -3 plus 6, right? And that equals to 4, 3. Right? 4, 3. So that means that x equals 4 and y equals 3. I'm done. I found x and y of the system of equations above by using the inverse. Okay? So once again, we started with this, and there was a way to find the answers by using the inverse of a matrix. Okay? So that's one way of doing it. Here's another way of doing it. The second way of doing it is called Cramer's rule. Okay, let me see if I can get the whole thing in the frame here. There you go. Cramer's rule. Now this looks more complicated, but once we do it, you'll see that it is just moving numbers around. Not a lot of math. So this one says you start with the equation, and then in order to find out what your variables are, say you have two variables, x and y, or x1, x2, say you have two variables. The first one is equal to the determinant, right? Remember, these bars mean determinant. The determinant of matrix A1 over determinant of matrix A, that's A, right? X2 is equal to the determinant of A2 over determinant of A. Now, you know what A is because it's given to you. What in the world is A1 and A2? Well, A1 is the matrix with the ith column, where the ith column is replaced by the constants in B. Sounds complicated. First of all, you have to know that when we say ith, it's just a way of counting. First, second, third, fourth, fifth, ith. Okay? So don't let that bother you. So again, I know it sounds confusing, but watch how we use and do exactly what it says up here. We do exactly what it says up here. So for this way of solving the equation, what you have to know is how to find the determinant only and how to find A1 and A2, but that's very, very simple. Here we go. Here's my equation, or I should say system of equations. Instead of xy, we're using x1, x2, but it's the same thing, right? So what is our A matrix, right? Boom, 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 boom. 3, 2, -4, -1. There it is. There's our A matrix. Now, how do we get A1 and A2? Because that's what we need, right? How do we get A1 and A2? Because we need A and A1 and A2 to get our answers. Well, here's A1. A1 looks exactly like A, except the first column is replaced by B, right? Where A is a matrix with the ith column is replaced by the constants in B. So ith column, first we're going to do the first column, right? We're going to replace the first column with B, right? It was 3, -4 in A, but now it's 6, -13 because we replaced the first column with B. What about the second column? Leave that alone. We only replace the first column. So that's A1. A2 is where we replace the second column with B. So instead of 2, -1, we're going to put B in there. There it is. Right? The 6, -13 is in the second column. And leave first column alone. So the way to get A1 and A2 is by replacing each column. A1, you replace column 1. A2, you replace column 2. If there was an A3, you would replace column 3. Right? If it was 3 equations. That's it. I have everything I need now. The original A matrix and the new A1 and A2 matrices. Right? Now, I need to quickly find discriminant of each one of them. Right? And put one on top of the other. Discriminant of A1 over discriminant of A. Discriminant of A2 over discriminant of A. And if there was a third one, you just keep going. So, back to here. So here's the discriminant of A, right? Multiply. I'm sorry. A1. Discriminant of A1. This is discriminant of A. Multiply across this way first, minus multiply this way. So 6 times -1 minus 2 times -13. That's the top. That's the discriminant of A1. What's the discriminant of A? 3 times -1, 2 times -4. There it is. And then minus, right? Minus 1 cross multiplication, right? The other. So that's x1. Let's do the math. That's -6. That's -26 minus -26 is plus 26. -3 plus 8, right? And you get 20 over 5, which means you get 4. Ta-da, we got it. x1 is equal to 4. So we got one answer. How do you get the other answer? Well, look up here. Same thing, except you do discriminant of A2 on top. Well, let's do that. There you go. Right? Let me get A2 in the shot here. So the discriminant of A2 is 3 times negative 13 minus 6 times negative 4. And what do we put on top, on the bottom? The discriminant A. Now, in the notes here, I wrote it all out, but really, we know what the discriminant of A is already. It's 5, right? Because it's a repeat from up here. So in the future, when you do the assignment, you can just copy that. Okay? So it's just 5 on the bottom. So let's do the top. What do we get on top? Negative 39 plus 24. We get the same thing on the bottom. And negative 39 plus 24 is negative 15 over 5. In this case, we got nice whole numbers, but you could get fractions. So as long as you follow the procedure, whatever the answer comes out to be, that's your answer. So what do we do here today? Let me go back. And let me zoom out a little bit. So we want to solve a system of linear equations, right? There's two ways of doing it. In the first way, what we did was use the inverse. So what we said was, in the equation, x comes out to be the inverse of a times b. So we found the inverse, multiplied it with b, and that's it. We found the answer. The inverse of a times b. Okay. The other way of doing it is called Cramer's rule, right? That's when you create two new matrices by replacing it with B, right? You create two new matrices, A1 and A2. Together with the original A, you find all the determinants and use the determinants as fractions, right? Division, to find the answers. Okay, how do you find A1 and A2? Well, we went over that. It's quite simple. You just replace the column with B. And once you find A1 and A2 together with A, you have everything you need in front of you. You find the determinants and work it out to get the final answer. So here we found 4 and negative 3. x1 is 4, x2 is negative 3. Okay, for those of you who are coming way, how do you say, you fast forwarded to the end just so you can see the notes. This is the beginning. This is the bottom of page 2. This is the top of page 3. This is the bottom of page, did I say page 3? Page 2. Okay, there were only 2 pages of notes. The timer says 13:28. That's less than 14 minutes. Not bad. Okay, remember, put question marks on anything you didn't understand, and that's the first thing we're going to do tomorrow. Answer questions and get into some try problems, and then get into the assignment. All right? See you tomorrow. Bye.